Ooh, we are getting into some drama today. It's going to be a polarizing episode on Seneca Prep as we go over polarity for your SAT chemistry subject test exam. Ooh. What we're going to cover, we're going over electronegativity. We're going to be going over how polar bonds form and how polar molecules form. It's going to be a lot to take in. I hope you're ready for this ride because it's going to be a lot, but it's going to be really fun and educational too. All those good things. What is electronegativity and what is polarity? Let's get straight into this. So, some bonds within molecules may be described as polar, and this is caused by differences in electronegativities. So, in a bond between two unlike atoms, one atom will have a stronger attraction to the electron pair than the other. This means the electron pair will not be at the center of the bond. And this will cause a buildup of partial charge on one side of the atom. And we write this as a delta positive or a delta negative. Delta is kind of like a weird looking D sign. Google it. The ability of an atom to attract the electron pair is called electronegativity. So how much an atom likes electrons and wants to bond to that electron pair is what we call electronegativity. Damn. So Pauling electronegativity. So the values of electronegativity can be measured on several different scales. The one you need to know about is the Pauling scale, and it's named after Linus. Oh, what a great name, Pauling, its inventor. So this can often come up in a lot of the time on the SAT subject test. They'll chuck in a random question with a bunch of scientists' names in it. So they have Rutherford, J.J. Thomson, all the people from atomic theory, and they might have Pauling as well. And they'll be like, which one of these is and then they'll be like, which one of these is associated with electronegativity? So you'd pick Pauling. The most important thing to take away from this, though, is the most electronegative element is fluorine, and it has a value of 4.0 on the Pauling scale. And everything decreases in electronegativity as you move away from fluorine. Other important electronegative elements are oxygen, which is 3.4. Coming in at 3.2, we've got our chlorine, and at 3.0, we have the diatomic babe nitrogen. So carbon has an electronegativity of 2.5 and hydrogen is around 2.2. So you don't need to learn those numbers. Just remember that super electronegative elements are fluorine, oxygen, chlorine, and nitrogen. Boom, you're welcome. So the most electronegative atom in a bond will develop a partial negative charge, and vice versa. And we call the charge difference a permanent dipole. So that's just a fancy way of being okay, this molecule's got some charge. So a good example of a polar bond is the HCl molecule. And a good example of a non-polar bond is the CH bond, because the electronegativities of hydrogen and carbon are super similar. So that bond is non-polar. It's nope, I don't want any drama today. I am happy in my non-polar life. All I want is some London dispersion forces. You'll see why in future episodes. So that's the key takeaway from that is remember the Pauling scale. Remember fluorine is the most electronegative element, and when you have a difference in electronegativities that between two atoms that are bonded together, that's when you develop polar bonds. And the special word for that charge difference is a permanent dipole. Whew, that was a lot of info. I'm feeling a little bit out of breath, imparting so much wisdom. So let's review that with a few questions. What's that most electronegative atom? It is fluorine. Remember that. Bonded and hard word to talk sometimes. We're going to keep going. Bonded atoms of different electronegativities form a polar bond, and we measure this with the Pauling scale. And an atom's ability to is the electronegativity is an atom's ability to attract an electron pair. Boom, boom, boom. Consolidation. So a CH bond is non-polar. Remember, that's because carbon and hydrogen have very similar electronegativities. I think it's 2.5 and 2.2, if I remember off the top of my head. Oh, look at this. I'm still learning too. So let's go over molecular polarity. So molecules can also be polar. A requirement for a molecule to be polar is that it has polar bonds. If there is a charge separation between one side of the molecule and the other, there will be a permanent dipole. So a good example of a molecule like this is chloroform, CHCl3. So those CCl bonds are going to be polar, the CH bond will be non-polar, but the molecule overall will be polar. Now, finer details. Honey, we are getting granular for you today. A molecule with polar bonds is not necessarily polar. I know, plot twist. What does it all mean? The prophecy is real. So, if the bonds are arranged in a symmetrical order about the center, the partial charges will be the same on each side of the molecule. What does that malarkey mean? Well, it basically means that the charges cancel out and the molecule is not polar. So a good example of this is tetrachloromethane. So that's CCl4. Now, in that molecule, there's a central carbon atom and four carbon to chlorine bonds. The carbon to chlorine bonds themselves are going to be polar because chlorine, very electronegative, carbon, not so electronegative. However, because the molecule is symmetrical, the opposite charges cancel out. So the molecule itself is not polar, okay? So even if there's a molecule that has multiple polar C to Cl bonds, the molecule might not be polar because the bonds may cancel out, okay? Do you remember the name of the scale to measure electronegativity? It is the Pauling scale or Pauling scale, however you want to say it. It's not an oral exam. You can say Pauling if you want to, or Pauling. Who knows? Whatever you want. I'm just here to support you. So is a molecule polar? So how do we do this? Let's make a little schematic. Is the molecule polar? Well, first things first, does it have polar bonds? If it does, it could be polar. Do the polar bonds cancel out? If they don't cancel out, boom, you got yourself a polar molecule. You're welcome. And a molecule is polar if there is a charge separation between each side of the molecule. So I'm going to give you 4 molecules. I want you to tell me which one's not polar. So we've got H2O, CCl4, CH3Br, or CHCl3. So all of those molecules contain polar bonds, right? This is also like SAT subject test loves this question. So these are all polar molecules, right? But CCl4 is going to be not a polar molecule because those bonds are going to cancel out. Boom, you're welcome. Signed, sealed, delivered. Polarity is done. You're welcome. We're done. We out. Keep studying hard. You got this. You're amazing. You're great. Thank you for joining me. Great life. Good life. Good life. Bye.